Okay, so we're solving radical equations, and we specifically picked to solve ones where you just have a linear equation underneath a radical symbol. So like this square root x plus 5 under the radical symbol instead of a quadratic. We still have to be able to graph those, but we're not going to solve them today. Okay, so solving radical equations algebraically. Step 1, always determine your domain first. This will help you understand if the solutions you find are in the domain of the graph. So can they even exist there, whatever you found? Number 2, you're going to isolate the radical on one side of the equal sign and everything else on the other side. 3, you're going to square root both sides of the equation to get rid of the square root. 4, you're going to solve for the remaining variable by isolating the variable, getting it by itself, like we've done so many times. And 5, last but not least, we're going to verify, check your solution, left side equals right side, like you've been taught since you were little. Sometimes you'll get answers that actually do not work when you plug them back in. So you get an answer when you solve it, but they don't actually work. So if you forget to check for extraneous roots, for roots that don't work, you're going to give answers that are actually not there, that might be outside the domain, or they might just not work. Okay? So we're going to solve the equation, square root x plus 5 minus 3 equals 0 algebraically. Now when it says solve, you guys, solve means every single time you see it, what is the variable? In this case, it's x, and what does it equal? Ultimately, in the end, I need x equals something, okay? And the great thing about solving is you can always check your answers to see if you have them right. You should be able to walk away from a solving question knowing, yeah, I got this right, or no, I need to go back and try again. All right? So the first thing we're going to do, we're going to solve the equation square root x plus 5 minus 3 equals 0. So the first thing we're going to do is we're going to look at our domain. What does that mean? Well, we have a square root symbol. The moment we have a square root or a radical, we have possibly x's that don't work, because if we use those x's, we would get negatives under that square root sign. Because we're doing linears, linears are the easiest. That x plus 5, because it's under a radical symbol, it has to be greater than or equal to 0. Okay? It needs to be. Because we can't have negatives under that square root symbol. You can't take the square root of a negative number. So when it's linear, it's easy because we can just set it greater than or equal to 0 to get our domain and then solve for x. So I subtract 5 from both sides and I get x is greater than or equal to negative 5. And there's my domain. And if I want to write my domain properly, I'm going to go x such that, squiggly brackets mean the set of x values such that x is greater than or equal to negative 5. Where once we do that, we know any of those values have to be real numbers. That's what x is an element of the reals means. And the squiggly brackets mean the setup, so they have to be squiggly brackets. They can't be square, they can't be round. Those mean different things in math language. So we know x has to be greater than or equal to negative 5. Well, let's try a value that's not. Okay? What's greater than or equal to negative 5? Let's try negative 6. That's not greater than or equal to negative 5. If I plugged a negative 6 in here, I would get the square root of negative 6 plus 5, which is actually the square root of negative 1. Can I do that? No. Could I plug in negative 5? Well, let's see. It says I can equal to negative 5. Negative 5 plus 5, which is the square root of 0. Is that okay? Yeah, that's 0. That's fine. We just can't have negatives. So if we get an answer, and that answer is not greater than or equal to negative 5, it's immediately extraneous. It means it does not exist. It can't exist on this graph. Okay, we've done our restricted domain. Step 2, isolate the radical, so square root symbol, and all of its stuff, on one side of the equal sign and everything else on the other. So I always rewrite my question, because if you're working your question off of the question that's typed for you, you could be working in the middle of the page or off to the side. So we always rewrite our question first, okay? Now, I want to isolate, get the square root, the radical, by itself. So I need to get rid of this minus 3. So I'm going to add 3 to both sides. And I'm going to get square root x plus 5 equals 3. Okay, radical on one side, number on the other. Number 2, done. Step 3, square both sides to get rid of the square root. So once my radical is isolated, which I have to do first, I square this side and I square this side, because what I do to one side I have to do to both sides. When you square just a square root, the symbol goes away. That's why you want to get that square root by itself. If you don't, you're going to have to FOIL. You're going to have to distribute, which is going to not be fun. So we want to get that radical by itself. So we did. We square the square root and we get x plus 5 equals 3 squared, which is 9. Step 3 done. Step 4, solve for the remaining variable by isolating it. So I need to get that x by itself. So I'm going to subtract 5. And now I get x equals 4. Great. I box it. I'm done. I'm never to do this question again. It's perfect. No. I have to be able to know, did I get it right? Walk away happy. Okay? So I have to check my domain. My domain says x has to be greater than or equal to negative 5. Is 4 greater than or equal to negative 5? Yes. So that's good. But I also need to physically check it back into the typed question. Now you want to fill it back into the typed question, because if you fill it back into anything else, you could have maybe wrote the question down wrong. So you always want to fill it back into the typed question so that you can find mistakes. If, for example, you copied it down as a +3 instead of a -3 out of this question, okay? So when we check, we always plug it back into what they gave us. So I'm going to put check. Or I could put verify. Verify is a nicer word. Mean the same thing. So I'm going to verify that x equals 4 is the solution, is an answer. So I'm going to plug it in. So I'm going to go square root 4 plus 5 minus 3 equals 0. And the key thing to verifying or checking is you never move anything from the left side to the right. You never move anything from the right side to the left. You literally just substitute in and then work your way down the left, work your way down the right, and see if you get the same answer. So square root of 4 plus 5 is square root 9 minus 3 equals 0, not moving anything from one side to the other. Square root of 9 is 3 minus 3 equals 0, and I get 0 equals 0. They match. Check mark. Yes, this works. I know my solution's correct. Third thing I want you to do, we are going to check with our calculators. Now, when you are asked to do this algebraically, if you use your calculator to get your answer, you're getting no marks. That's not algebra. That's graphically, okay? But we are going to check graphically just to make sure that we did it right. So we have a verification algebraically, which we need to do, and then we're going to verify graphically. We're going to do both ways. So we'll walk away from this question feeling very confident. So how do I do it graphically? I go to my y equals, and I type in the equation the way it was given to me. So on the left side, I put what's in the left side. So on the left side, I had square root x plus 5. Arrow over minus 3. That was what I had in the left side. In the right side, I have a 0, so I'm going to put a 0. If you don't have the fancy colored ones like I do, you could arrow over here onto the slash line and hit enter, and yours will actually become thicker. Okay? Mine's a color, which is great, but if you don't have that option, then you can make that line thicker. Okay, so we're going to press graph. Look at my two lines. I'm going to find out where they intersect. So I'm going to go zoom 6, sorry, because I have it still set at a trig window. So I want you to see. It looks like it's intersecting at 1, 2, 3, 4. Looks like we're doing good because we're trying to find out where these two graphs intersect. How do we find out where they intersect? We do second trace, because behind trace is calc, and we want to calculate the intersection. So we're going to go second trace. It shows it down here. Second trace intersect, which is number 5. See, it shows it down here, number 5. And then it says first curve. I'm just going to hit enter. And then it says second curve. It moved on to it, so I'm going to hit enter. And then it says guess. I'm going to hit enter. And it tells me the solution, and I only look at the x. It's 4. I just verified graphically too. I'm walking away from this question feeling perfectly confident because I know I got it right. I did it algebraically. I checked it algebraically, and I checked it graphically, and I have my domain, and it fits in there. We're good. So there's my solution. So using a calculator to determine the x-intercepts, well, whenever I read x-intercept, I know that y equals 0, right? So I'm going to put a 0 in for my y if I want to. And I could just go y1, y2 again, like that. Or I could just plug this into my y equals of my calculator and find my x-intercepts that way, okay? Now, describe the connection between the solutions of the equation and the x-intercepts. The solutions are the x-intercepts. art. Not right. Are the x-intercepts. What else could we call x-intercepts? Well, they have so many words. They could call it an x-intercept. They could call it a root. They could say, look for the roots. Or they could ask you for the zeros. Those are all the same words. I know, so nice. They give you so many options. But they're the same thing, okay? And solutions is the same thing. So it asks you to solve. You're finding the roots, the zeros, the x-intercepts. Okay? So this one's your turn. So you're going to try it on your own, and then you're going to watch and see if you got it right, okay? So you pause it right now. I'm going to keep going. So solve the equation, this, algebraically. So if we want us to solve it, y is going to equal 0. So we're going to go 0 equals square root x plus 2 minus 4. Algebraically, check your solution, verify graphically. So, like I said, you would turn this off and you try it yourself now. First thing I need to do is restrict my domain. So I'm going to go x plus 2 has to be greater than or equal to 0 because it needs to be positive because it's under a square root symbol. Subtract my 2. X has to be greater than or equal to negative 2. The only thing that happens different with an inequality, so a greater than or equal to sign, and an equality and equal sign is if you divide by a negative when you're solving for getting your x by itself and you're isolating it in this domain, if you divide by a negative, that inequality is going to go from a greater than to a less than. So don't forget about that. All right. So first step, domain, we did it. X has to be greater than or equal to negative 2, or you're going to get a negative under your square root. So that's my domain. I'm going to write it up. Now, next step, isolate the radical, get it by itself. So I'm going to add 4 to both sides. So I get 4 equals square root x plus 2. Next step, square the square root so that it goes away. But what I do to one side, I have to do this other side of the equal sign. So I'm going to get 16 equals x plus 2. I need to get x by itself, so I'm going to subtract 2. X equals 14. Let's check it algebraically or verify it. We're going to verify x equals 14 is an answer. So we're going to go 0 equals square root 14 plus 2 minus 4. 0 equals square root of 16 minus 4. 0 equals 4 minus 4. 0 equals 0. So whenever you solve, remember your y equals 0. So when you verify, your y is still going to equal 0. They match. Woohoo! Okay. We're going to verify this using our calculator. You can use the y equals. I like using y1 equals 0 and y2 equals the other side. So I always make the left side equal y1 and the right side equal y2. So now this time I have my y1 equals 0 and my y2 equals square root x plus 2. Arrow over, so you get out of that radical sign, minus 4. Graph. So I'm going to go second, trace, intersect, enter, enter, enter. What? No sign change? What does that mean? I knew this was going to happen and I set this up because if your calculator, so we're going to press go to every time. Great. If my calculator, I press my graph, if my calculator can't see where it intersects, remember it intersects at 14. So that's like out here. No, that's like 12. 14, because this is 10. 14, it's intersecting here. If your calculator can't see where it intersects, it can't calculate it. So if I know my solution's 14, which I knew because I already found it algebraically, I'm going to go to my window and I'm going to make my x max, make sure that it has that in it. So I'm going to make my x max be 15. Now I can actually see where it crosses. So I go second, trace, 5, enter, enter, enter. And now it gives me the answer 14. Before it couldn't because my x max was 10. It couldn't see it. So if it can't see where your solution is, if your solution is not in your window, then you're not finding it. So remember, we have to go to window and we have to make our x max be at least 14. All right? So we verified it. So this is a solution, x equals 14. Okay. Solve the equation square root x plus 5 equals x plus 3 algebraically. Check your solution, verify graphically. So the first thing we're going to do is our domain. So I'm going to say what's underneath that radical, x plus 5 has to be greater than or equal to 0. It can't be negative. And I'm going to solve it. I'm going to subtract 5. X has to be greater than or equal to negative 5. That's my domain. X such that x is greater than or equal to negative 5, XER. Could do it in interval notation. So it's be greater than or equal to negative 5. So it's equal to negative 5. So that's my lowest. And it's equal to, so I do a square bracket. So it's greater than negative 5. So I'm going to go from negative 5 to positive infinity. And I'm going to have a round bracket on infinity. I always have a round bracket on infinity because you can't equal infinity. It's a concept. It's not a number. Okay? So infinity is negative and positive will always have a round bracket. All right. So step 1, rewrite the question. That should be actually my first step. I should have wrote that down. Okay. Step 1 was domain. Step 2 was isolate the radical on one side and everything else on the other. It already is. I didn't have to do anything. The radical's on one side, the x plus 3 is on the other. Next step, square your square root so it cancels off. And what you do to one side, you have to do the other. Okay. What I always tell people to do is when you see an x plus 3 to the 2, I always cross the 2 out and I just rewrite it again. Because if people don't rewrite it again, they won't FOIL it, and they'll often miss the middle term. They'll tell me it's x squared plus 9. It's not x squared plus 9. When you x plus 3 squared, it's x squared plus 6x plus 9. So whenever I have a binomial, an x plus 3 squared, I immediately cross the squared out and I rewrite it twice so I don't miss my middle term. So the squared cancels off the square root. I'm left with x plus 5 equals x squared first, outer or outside plus 3x, inside plus 3x, last 3 times 3, 9. And I get x plus 5 equals x squared plus 6x plus 9. I just collected this 3x and 3x. Now, if it's linear, you isolate the variable, get it by itself, and you're done. If it's a quadratic, and this was drilled into your heads in grade 11 over and over and over, whenever you have a quadratic or an x squared, you have to move everything to one side, set equal to 0. So I'm going to subtract the x over. I'm going to subtract the 5 over. And now I have 0 equals x squared plus 5x plus 4. And then I can try and factor it. How do I factor again? I do, which is going to end up being just a factor. Product sum, what times what equals, the first times the last. So 1 times 4. So 4. And then I go what plus what equals the middle, positive 5. So what multiplies to give me 4 and adds to give me 5? 4 and 1. Let's check it. 4 times 1 is 4. 4 plus 1 is 5. So my terms are 4 and 1 that I'm going to use for my factors. I can go directly to brackets. I don't have to do decomposition only because I have a 1 in front of the x squared. If I had a negative 1 in front of there or a number, I would have to do decomposition. Okay? But I don't have to because I have a positive 1. So I can go right to brackets. I'm going to get an x plus 4 and an x plus 1. Then my next step is to set each of them equal to 0. So I'm going to go x plus 4 equals 0. X plus 1 equals 0. Then solve for x. Subtract 4. Subtract 1. X equals negative 4. X equals negative 1. Two solutions, box them, move on. No, we have to verify. So we're going to have to go over here and we're going to have to verify each of them separately. So I'm going to verify x equals negative 4. So I should never box those until I'm actually done verifying. Verify x equals negative 4, and I need to verify x equals negative 1. Because one of them could work, both of them could work, or neither of them could work. So we have to check. Both of them fit in the domain. The domain is greater than or equal to negative 5. Both negative 4 and negative 1 are. But I have to make sure that they actually work in the question. So I'm going to plug them back into the original. So I'm going to plug them back into here. So I'm going to get square root x plus 5. X in this case, though, is negative 4. So negative 4 plus 5 equals negative 4 plus 3. So I'm just plugging negative 4 in for the x's. Negative 4 plus 5 is 1. So square root of 1 equals negative 4 plus 3, which is negative 1. 1 equals negative 1. No, it doesn't. 1 does not equal negative 1, actually. And x does not equal negative 4. X does not equal negative 4. Well, technically, x still equals negative 4, but it doesn't work. So x equals negative 4. What we should be doing is we should go x equals negative 4, circle it, put a line through it, and say extraneous. The solution does not work. I'm just putting that as an aside for you to know. The solution does not work. It does not work in this question. It is extraneous. It is an answer when you solve it algebraically, but that answer does not work, so it is extraneous. Let's try the negative 1. So we're going to plug it in. Square root negative 1 plus 5 equals negative 1 plus 3. Square root negative 1 plus 5 is 4, equals 2. 2 equals 2. Yes. So x equals negative 1 is a solution. This one is not a solution, the x equals negative 4. And now some people think, well, one of them always has to be a solution. No, actually, a radical, when you solve it, could have no solutions. Okay? So both of them could not work. Both of them could work, or only one works. So you have to check them or you won't know. Well, we're going to check it with our calculator. So we're going to take the original of what's on the left, we're going to plug into y1. What's on the right, we're going to plug into y2. So when we check this in our calculator, this is going to go into y1, this is going to go into y2, and we're going to find out where they intersect. And remember, if it says no sign change, that just means your window isn't big enough. It doesn't contain the x you're looking for. I'm going to go square root x plus 5. Oops, my y1. It doesn't really matter if you swap them, but I like being consistent. Square root x plus 5, and then in y2 you get x plus 3, not 33. So in y1 I have square root x plus 5, and y2 I have x plus 3. I'm going to press graph and see if I can see. Ooh, they look like they're crossing in one spot. Second, trace 5. Enter, enter, enter. And look at my solution. Negative 1. I don't care what my y is. I only care what my x is. So I've proven twice the only solution is negative 1. Negative 4, it's not crossing there at all. Right? Here's negative 4. Is that graph crossing at negative 4 intersecting there? Nope. Negative 4 is not a solution. Okay. This one's your turn. So you're going to pause it now and you're going to try it yourself. And then you're going to come back and check and see if you got the same as me. 4 minus x, rewrite it, Square root 6 minus x. So the first thing I'm going to do is my domain. So I'm going to go 6 minus x has to be greater than or equal to 0. And I'm going to subtract 6. You could add x too, wouldn't matter, but I'm going to subtract 6. And so I'm going to get negative x is greater than or equal to negative 6. And then I'm going to divide by a negative 1. And when I divide by a negative 1, my x becomes less than or equal to positive 6. So if I divide by a negative, my inequality sign flips. So my domain in set notation is x such that x is less than or equal to 6, xer. And it's less than or equal to 6, I'm going to go from negative infinity to 6. Close bracket because it's equal to, round bracket because infinity is never equal to. Okay, my first step, get the radical on one side, everything else on the other. Already done. Second step, square the square root. So that cancels. Square this side. And what did I tell you to do when you square that side? Immediately cross that squared off and rewrite it again so you don't miss the middle term. Which you will, promise you. You'll miss the middle term if you don't rewrite it. Now we FOIL. 4 times 4, 16. 4 times negative x, negative 4x. 4 times negative x, negative 4x. X times negative x, positive x squared equals 6 minus x. 16 minus 8x plus x squared, I just put these together, equals 6 minus x. And it's because it's a quadratic, because you have an x squared, you immediately have to move everything to one side and set equal to 0. So I'm going to subtract 6, and I'm going to add x. So I get x squared minus 7x plus 10 equals 0. Now I'm going to factor. Once again, I don't have to do decomp, locked out. There's a 1 in front of here. So I'm going to go what times what equals the first times the last. So 1 times 10, positive 10. So what times what equals 10. And then what plus what equals the middle term, which is negative 7. So what multiplies give me positive 10 and adds give me negative 7? Negative 5 and negative 2. And I can go right to brackets because I have a plus 1 in front. So I get x minus 5, x minus 2 equals 0. Set each equal to 0. X minus 5 equals 0. X minus 2 equals 0. Add 5 to get x by itself. X equals 5 we think might be a solution. Add 2. X equals 2 might be a solution. And if this was a multiple choice, I'd give 5 and 2 as one of the answers, because if you forget to check and one of them doesn't work, then you didn't do your whole question, you're going to get it wrong. So we need to verify. So I'm going to verify x equals 5, and I'm going to verify x equals 2. I plug it into the original, so I'm going to go 4 minus my x, which is 5, equals the square root of 6 minus my x, which is 5. 4 minus 5 is negative 1, equals the square root of 6 minus 5, which is 1. Negative 1 equals 1. No. Nope. So x equals 5, draw a circle around it, draw a line through it, is extraneous. It is not a solution to this, actually. It's a value of x, but it doesn't exist on this graph. It's not a solution. X equals 2. 4 minus 2 equals the square root of 6 minus 2. 4 minus 2 is 2, equals the square root of 4. 2 equals square root of 4, which is 2. Yes, so this one works. X equals 2 is a solution. Now I want to reiterate for the last time, you can get 2 solutions. Now both of them can work. Both of them could verify and work. One of them could verify and work, and one of them could not. Or I could plug both in and both don't work. That can happen, okay? There's no saying that one has to work and one doesn't. Both could work, one could work, or none could work. So you always have to check them. Always, 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 always. Now we're going to check with our calculator again. So we're going to type the left side into y1. and this one into y2. So into y1 I have 4 minus x, and into y2 I have the square root of 6 minus x. Graph. Now I can see where they intersect, so I'm going to check it. Second trace 5, enter, 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 and the answer is 2. The other answer was 5. Let's check it out. 3, 4, 5. No solution, right? It's not crossing there. Even though both answers were in the domain, they both don't work. Now you can go and do the practice questions from the textbook and the questions that are in the assignment once you're done all of your lessons.